On this episode of Coding 101, it's the best of 2014.
Netcasts you love.
From people you trust. This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
Welcome to Coding 101. It's the Twit show where we let you into the world of the Code Monkey. I'm Father Robert Ballecer, and this is our 2014 best of episodes. That's right. We're going to take you through some of the best moments of Coding 101, some of the best interviews, some of the best segments, and some of the best juicy bits of code to distill it down to what it means to be a Code Monkey. So without further ado, here's the best. Mr. Liam Kennedy. Liam, thank you so much for coming up.
Thank you for inviting me.
Now, you're from Pasadena, right?
I am, yes. I'm the little old coder from Pasadena, yeah.
Yeah, so the home of the Big Bang Theory.
The home of the Big Bang Theory, and yes, if you sort of look at what I've got going on here in front of me and imagine my house, we've pretty much been living in the Big Bang Theory in my house for the last 3 months.
Now, Liam, before we get into the wonderful hardware that's in front of us, could you just give the Twit Army, the Coding 101 Code Monkeys, a little idea of who you are, where you come from, and why you're standing in front of the ISS above?
Sure. So, firstly, the ISS above, obviously what it does is, on the basics of it, it just lights up whenever the space station is around, which happens more frequently than you'd imagine. But my interest in the ISS is really what brought me to develop this. So for many years, I've been passionate about public outreach for astronomy.
Oh,
and
cool.
a common, yeah, there you go. And a common thing that I would always get involved in is looking out for when the space station is coming over.
How do you go about moving from, I like the ISS, I like space exploration, to, I'm going to make a Raspberry Pi program that can tell me when it's above me?
Yeah, so I'll go back 3 years. I think this bears mentioning. 3 years ago, I heard about a project, another project called ISS Notify, that was going to create a little Arduino-based device that would light up whenever the space station comes over. And I backed it, along with quite a few other people. And after seeing a lot of great progress by the creator for a couple of years, then it just looked like things just stopped happening. So, and there's, you can speculate as to why that happened, but the end result
Sometimes it
is,
happens.
yeah, so 3 years, and I didn't have this cool little device that lit up when the space station came by. So I just really just gave up waiting and decided to see what I could create. And thankfully, in the time that elapsed from then to now, we ended up, building the Raspberry Pi version.
Why would you choose the Pi over anything else? Was it just convenience? Was it just because you already had one for this other project?
So I would say it was a matter of coincidence that I happened to have the Raspberry Pi in front of me. But I did some very quick testing of what I needed my code to do, and it's perfectly adequate for it. Absolutely. The other project, I believe the way it was going to work was pull information every few days off the web from some websites out there that list the same data.
Oh, right.
But my code actually does all of the calculations for where the ISS is on the device. There's basically a standard library you can get called FM. It's spelled EPHEM. It's for ephemeris. It's an astronomical term. And I use that to do the calculations on the device, and it works just great.
Wait. So I was under the impression that your project scraped some sort of publicly available database to say, oh yeah, it's over your latitude and longitude. You're saying the Pi would know just because of the calculations you've programmed in.
Yeah, I tell you, if I didn't need the access to the internet for the clock, you could just unplug it from the internet and it would just work perfectly well. What it does pull down every few days is what's called the NASA two-line element. It's actually basically a set of data points that defines the orbit. And NASA updates that every few days. They probably update it minute by minute. But they, the ISS shifts its position.
Right.
Usually it's dropping down naturally because although it's up in space, it's still impacted a little bit by the upper atmosphere. So it tends to drag itself back down, and then they use rockets to push it back up again.
A Soyuz capsule to push it back up into its proper orbit.
So the equation has to be updated. So that's what this the Raspberry Pi does use the internet for, is to pull down that information every few days.
We've got people in the chat room who actually, they're impressed. They understand what you're trying to do. We have Eric Duckman and Bevo who are both saying, look, the calculations to do that, the number crunchings that you have to make your Pi do in order to figure out the orbit, that's not trivial. That's actually a lot of work.
It is, and I am not a rocket scientist, so I really couldn't do that math. But this library that you can get, it's just you install it with one line. You've seen it, sudo whatever it is, apt-get blah blah, or pip python install whatever it is. I've forgotten it all. And then there's the FM library, and then you can then start coding against that yourself. And of course the code is visible for anyone to see. You can look at what I've done.
Okay, so you had this code figured out, all the mathematical equations to find the ISS above you at a certain time.
Yes.
And you figured out that you can put this on a Raspberry Pi. What's next?
Well, what's next was just figuring out how I could use the Raspberry Pi display options to, indicate what's going on. And that's really what you see in front of you here.
That's why we have these LEDs blinking.
Yeah. So I've always enjoyed anything with a blinking light.
Well, you know what? Yeah, let's get into the hardware. Because our guys love hardware, and we've got all these wonderful boxes sitting in front of us. Tell us, what are they doing?
So so where do I start? I'll start with this one that is just very easy to look at, right? Oh, maybe I'll go over here, depending. Oh, here we go. So this is the basic one with the Raspberry Pi platform, and it simply has a very simple display on it called a Pi Glow.
It's a shield, right? It plugs right into the GPIO.
Yeah, it plugs into the GPIO port, and in fact, you can even see that I haven't put it in very nicely there. But that's all it is. And then I just program the light to do a certain sequence based on where the space station is. This is another version. This is with...
So that one's blinking.
Yeah, and this one, if you count the number of green flashes, let's see if it's going to do it at 1, 2. Okay.
Oh, 4, 5.
6.
6.
Okay, so if it's approximately an hour or less, the ISS above flashes green the number of times for the number of 10-minute intervals.
Perfect.
So now I have messed around with the time on these, so I'm not sure if this is real time now. I don't think it is. But so essentially that says it's up to 60 minutes away from the next pass of the ISS. So, and not all the passes are visible, but and that's why I've got another website. So the other thing I've got going on here, you were talking about just the Raspberry Pi being underpowered. Well, just think of this. This thing tweets. So when the space station is is particularly close to you, all of the lights on here really start going crazy. But it also sends a tweet.
So I could program it to say, oh, the ISS is above me.
Yes.
Does it tweet to the ISS?
Well, yeah, it sort of. It tweets to the ISS by tagging at the request of NASA. So during the Kickstarter program, they got wind of what was going on, and their public affairs coordinator at NASA Johnson Space Center, which is mission control for ISS, sent me an email saying, could you please make sure that you tag at NASA_Johnson.
Great.
So that was neat. They also do tweet to at ISS_research, which is the research arm. They're the organization for NASA that actually determines what research is done on the space station by the astronauts.
So they're receiving thousands of tweets from all your pies saying, hey, I see your ISS.
Well, yeah, and that gives that's a good point. So I've run a Kickstarter that was very successful, but before that, I wanted to make absolutely certain that people wanted this, and also that they could see that it was working already. So,
Absolutely.
you know, bearing in mind the other Kickstarter didn't fulfill its, what it was gonna do.
Wait,
so I created a beta program, and I was heading over to the UK in December, and I installed a couple of them in my grandkids. So the grandkids got them. And then there was a post on Hackaday and on Reddit. And then people suddenly started to approach me saying, hey, can I get in on this beta program?
Wow.
So I had about 20 sites. So what you're seeing right here now are the tweets. So I'm just on my page here. You'll actually see the tweets that are coming from those beta sites that are around the world.
Nice.
That's so cool.
And the way it's done is this little device is posting to my WordPress site, and the WordPress site is sending the tweet.
What I like about this is you're leveraging a lot of existing tools to do something that's very different, and that's very much in the hacker spirit. We want to talk about Heartbleed because it actually addresses something very, very basic in programming, and something that's very important. It's all about sanitizing inputs. It's about
Sanitizing your comments.
sanitizing your code.
Yes,
You have to
totally.
make sure that the data that you receive is what you expected.
Exactly.
And unfortunately, the writer of the piece of code in OpenSSL that is responsible for the Heartbleed bug didn't do that. Now, Brian, you actually have a link for the GitHub that has all the OpenSSL code. While you get that up, let me really briefly state what's going on in the Heartbleed bug. So what we're talking about is the heartbeat. Anytime I established a secure connection, so Snubs, let's say that you're Facebook, okay, you're the Facebook server. I'm talking to you. You know how that you get that little padlock in the upper corner of your
Yes.
browser? It tells you that you're secure, right?
Yeah. It tells me I'm using HTTPS.
Exactly. I've Secure Sockets Layer or TLS, which gives me an encrypted tunnel between the client and the server. You're the server, I'm the client. Now, that's a good thing, because without that, anyone could just snoop in on our conversations and they could read everything that I'm sending and everything that you're sending back to me.
Especially if they have a Wi-Fi pineapple.
Brought to you by Hack5. No, but see, here's the thing. I can't just keep those open. Right? Once I've established one of those connections, I need a way to tell the server that even when I'm not using it, let's say I'm reading something that's on my page and I'm reading it for 3 minutes, my client, my computer, still needs to be able to tell the server, I'm still connected, I still need you, don't shut off the connection.
So this is the heartbeat that's
This is the heartbeat.
between us.
Right. It's a nonsense piece of data. It's a minimal data set. It's a very small handshake, very small packet, essentially saying, keep me alive.
Okay.
Keep me alive. Keep me alive. And it does that every once in a while.
So why do we have these jelly beans up here?
Okay, so this is your system memory. You're the server, right?
Oh yeah.
Don't eat your memory.
I won't eat my memory.
Just gonna eat all the memory. All right, so
My hard
you
drive just failed.
now this one jelly bean, this is my heartbeat packet.
Okay.
Okay, so what I have to do is I have to send you two things. I have to send you my payload, and the payload is the jelly bean, right? But I also have to send you a description of how big this is.
Ah, okay.
So in all non-open SSL implementations of SSL, of the secure sockets layer, of the encryption, whenever I, the client, send something to you, the server, you check what you received against what I told you I sent.
Ah, okay.
So let's say I do this. I go ahead and I say, I'm sending you one jelly bean. I give it
I
to you.
just received one jelly bean.
Right, and that's it. And so you said, well, you told me that you sent me one jelly bean. I
It
read
looks like
that
a jelly
it
bean.
looks like a jelly bean, and now you send it back to me.
I'm sending you one jelly bean.
And there we go. So now the connection stays alive. If I did this, I am sending you 5 jelly beans, and I give that to you. What do you think you as a server do?
I only have one jelly bean.
That's it, right?
This is odd.
This is odd.
Hacks.
It'll kill the connection, right? Or it'll ask for the heartbeat again.
Right.
That's simple checking, right? That's sanitizing your inputs. That's making sure that you've actually received what you expected to receive. That's good
That makes
coding.
sense.
That makes sense.
Yeah.
there's a bug in OpenSSL.
No!
Yeah. And Brian, if you go ahead and bring up that GitHub, it'll actually show you the code that goes behind SSL. Now go ahead and forward, what line was that? We need you to go to line 3972. There, right there. See, so you see where it says read type and payload length first. These next 4 lines of code, actually 3 lines after the comment, are entirely responsible for the Heartbleed bug. Now let me explain. This looks kind of crazy, but let me explain what's here. HB type is just setting the type of data. Okay, so that's like from C# that just says this is the kind of data I'm going to be receiving.
Okay.
P++, we've seen that. It's incrementing the counter. So it's P plus 1, right?
Plus 1, yeah.
Now here's the big line. NS2, which is calling a function, because we know it's in parentheses, right? So it's calling a function, and it's passing it 2 parameters. P is the location, it's called a pointer, of the payload, the jelly bean. So it's telling it where the jelly bean is located.
Okay.
Right? Payload is the length. That's me telling you I'm passing you 1 jelly bean. Okay? Now a good piece of code would have had an extra line here that says, is P, the length of P, equal to the length of payload?
Right, yeah.
Right? So if I told
It
you...
would be sanitizing their
It's
code.
sanitizing the code, sanitizing the input. It's saying, if I told you I'm giving you 1 jelly bean, what is P? How long is P? Is P actually 1 jelly bean? If it is, allow it. If it's not, then X. Kill the connection.
And since they didn't do that, there is no line that says if it's this long, then it should equal P.
Right,
That
right.
pretty much means that the payload could be as long as they want.
Or short. So this
Or
is how
short.
it works. If you come back to me, now we're talking about this jelly bean, all right? So I'm still talking to you in the server, and I'm passing you this 1 jelly bean, and I'm saying, I sent you 64,000 jelly beans.
It looks like 64,000 jelly beans.
That's how OpenSSL works. Because it doesn't check, it's just going to trust me. And unfortunately, that's not good. So what it's going to do is it's going to say, well, he must have sent me 64,000 jelly beans, so I'm going to send him back the 1 jelly bean plus 63,999 jelly beans he shouldn't have received.
so
which means I take your system memory,
Hello, hacks.
and it's all for me.
Oh, that's bad.
Hello hacks, exactly. and see, the problem with that is they can do it over and over and over, and each time they'll get a different set of the memory until they can put it all together, and they can essentially have everything.
And from the server end, everything looks cool, so nobody ever checks for any difference.
To the server end, if you're using OpenSSL, the unpatched version, all it knows is that someone's sending a lot of heartbeats. And that's normal because that's how we keep the connection open. It doesn't realize that it's giving away the keys to the kingdom every time it sends you that 64K.
Authorization acknowledged.
Precisely, exactly. We got a computer fault. So that's how Heartbleed works. And go back to that code, Brian. This is the crazy part. This is what we're trying to drill into you people. When you're writing your code, you got to make sure to check for things like that. This was an innocent mistake. This was, again, we know that this was submitted something like, what was it, an hour or 2 before midnight 2 years ago, December 2011.
Right.
So it was probably some guy staying up late, writing some code. It looked right, it worked right, but he never actually made sure that he was receiving what he was supposed to receive.
Oh man, I feel
Simple
bad
mistake.
for that guy.
I feel bad for him, but you know, simple mistake that anyone could make.
Yeah, it's true.
Yeah.
That's unfortunate, but it's a good example of what can happen if you don't sanitize.
Very good example. Who do we have this week, Shannon?
This week, I'm super excited about this because I'm kind of a fan. This is Randall Schwartz with his Pearls of Knowledge. I just like saying that because I think it's hilarious.
Cool.
Hi, Randall. How are you?
Randall
Hi.
Schwartz,
Hey.
the host of Floss Wednesday, the earliest show on the TWiT TV network. Thank you so very much for coming.
Oh, yeah, and actually I got to sleep in a little bit today, too, which is really nice. So
Nice.
time for my other show. Yeah, no, great.
We don't do sleep.
Thanks for having me on.
Yeah, we don't do sleep
Yeah,
on
we
the
never
TWiT TV
sleep
network.
here.
No. Well, the reason why we asked you to come in is because you are one of the acknowledged experts in Perl, right? I mean, you've written a series of books about Perl, you teach Perl, you talk about Perl, and more importantly, you program in Perl.
Well, I program in a lot of languages, but Perl's maybe the most money over the last 25 years. Exactly. I wrote the top 5 selling best-selling books, and the 255 magazine articles. And yes, I ran a training company that was extremely busy during the late 90s as the dot-com boom rolled out. It's not so much, it's much more in mothballs now because there aren't 20 people wanting to learn something about Perl sitting in one place for a week anymore. So I don't do much of that. Perl's only like one of the 70 languages I list on my resume. So I've got plenty else to talk about besides Perl too.
Now, Randall, we want to talk a little bit about something that I actually asked you beforehand because I wanted to make sure you were comfortable with this.
Oh, yeah.
You are, I think, the only host on the TWiT TV network, and definitely the only guest we've ever had on Coding 101 who at some point had a felony on his record.
Mm-hmm.
Yeah. Now,
Indeed.
this stemmed from a 1995 case brought against you by the state of Oregon. Not a financial case, by the way. It was actually a criminal case stemming from your time as a system administrator from Intel.
Yes.
Doing some very standard system administrator stuff, and I like to think that this is one of the very first cases in which the law didn't quite understand what people in computer science did.
It still doesn't.
And it still doesn't, right. But this is one of the very first great examples of, wait, he got in trouble for what?
Yeah,
can you explain
exactly.
how this happened, what happened, and then talk a little bit about how your record got expunged?
Yeah, so 1990 through 1993, actually. From 1987 to 1993, there we go. I was a contractor at Intel in 7 different slots. One of the things about being a contractor is you're always looking for, doing the items 1 through 10 that the boss wants, but also looking for item 11 that shows that you're still valuable in some way because you're bringing something to the table. You're not just being the code monkey that's doing the things that are on the table. And I would do these sort of odd projects from time to time. I'd see something that needs to be done, I'd just go ahead and do it. And I got really practiced at that. Well, the thing that, the particular thing that we have in question is I was running Crack, which is a standard tool for evaluating the strength of passwords in the Unix system. I was running Crack against the password file of the current group that I was in. Well, there was only like 5 passwords in there, so it didn't show up anything. And Crack, I think 3.0 had just come out. So I was actually testing the new version of Crack. Again, I'd done all my stuff for the day. I thought, well, I'll try this out. Well, I still had access to the previous group where I was one of the key system administrators, and I'd moved on to the new group, but they still gave me access previously to the previous system because I was still maintaining some code for them. And I ran Crack against this much larger password file. And something like, I forget the number now, something like 67 of the passwords were guessable. Now, this shocked me to no end because I was, when I was in that group, I was running Crack against the local password file, and I made sure, anybody that got guessed, I would, and this was complex things like, like the word hello with the E changed to a 3, it would find stuff like that, and the O changed to a 0. So it would find these sort of normal, combinations of things, people's first names, pet names, things like that. It would look for all that stuff. And it was really good at doing that. I actually met the author of Crack a few years ago, cool guy. So I couldn't imagine that, 67 passwords were guessable. Now, what I didn't realize at the time was one of the passwords was the vice president, and his password was president with the S changed to a $sign.
Oh.
And I suspect that's why I got prosecuted, because I actually embarrassed somebody. Now, I was going to go over to the group and say, to the people who had taken over my job, essentially, at the other group. But I then realized, wait a second, I'm going over to tell them they're not doing their job. How do I do that? I spent a few weeks sort of kicking back, trying to figure out how to do this best. In the meanwhile, somebody at my new group noticed I was running Crack and running against the password file of the old group and didn't understand my motivation. I was just simply trying to do one of these things again, where it's like, the 11th item on the 1 to 10 list. And never intending any harm to anybody, not trying to do anything at all. But, the problem is, they showed up at my house, they took my computers away, they only returned them like 4 months later. Now imagine, having all your data in your computers and then not having them for 4 months. It was just really crazy. And they didn't arrest me until they put out a warrant for my arrest 4 months later, which shows you they had to figure out, okay, wait, we've accused him of being bad. He's only done exactly what he told us he was doing. And with the intentions probably that he told us he was doing it. So now what do we do? Well, it turns out Oregon's computer crime law is overbroad and vague. Basically, if I pick up your cell phone and I change the background color on the screen, that's a Class C felony, $100,000 and 5 years in jail. So the law is way out of proportion in this thing. And so I got basically nailed with a law that makes criminals out of anybody they want to prosecute. And I got 3 felonies eventually in 95 convicted on me. And it was devastating. I gotta tell you, I was suicidal for a few times, because here's the thing, since 10, I wanted to be a programmer, and I said, who's going to hire me now? But luckily, I had a lot of friends come forward, and they brought me into their companies and stuff. So it was quite a transition period. And then about 10 years later, you're eligible for expungement in Oregon. So I applied for that, and so technically, I can now tell you, I've never been convicted of a crime in my life. But it doesn't matter as far as the feds go, apparently. So I can't get like a global early entry. I have troubles going to Australia and Canada still. I can go anywhere else in the world, just can't go to Canada and Australia. It's just very, very weird.
Of all places.
Yeah, of all places.
Now, Randall, this is interesting. You bring up a great point, and actually, I think there's a lot of programmers out there, and especially a lot of programmers who might know Snubs, because Snubs has a couple of the shows, and one of them specifically talks about security.
We've dealt with banks telling us that we can't have a checking account with them because of the name of our show. It's called Hack5, and people have told us that we can't get jobs because of the name of our show. My friend had a problem getting a loan for his house because of it, and it's ridiculous how feds and how a lot of government companies look down at us just based on the fact that we know how to do these type of things. It's just kind of irritating.
And the thing that hits me the most is something that Randall alluded to, which is these overbroad laws, which that's one thing. If most laws are overbroad, they try to catch all the outliers. But the very selective way that they are applied, and it always seems as if it's not every hacker who's going to get persecuted. It's going to be the hacker who insulted or embarrassed the wrong person that the book is going to get thrown at.
Exactly.
And I know you touch on this in Floss, which is why it's a great program to watch. Even though it's early in the morning on Wednesdays at 8 o'clock on live.twit.tv, it's something that you should watch because they talk about cases like this. Well, I think what I'd love to hear from you is, looking back on your experience now and knowing that there's a new generation of programmers and there's a new generation of people who are going to be curious about the networks that they're connected to, there's this little air of insecurity about, well, this seems really easy, but someone's telling me that this is a crime. Like, for example, I'm on a network and the system administrator knows absolutely nothing about security, and for some reason I can access all the files of all the executives because it's a standard Samba share with no protection. But for some reason, if they accidentally click into one of those folders, they're now guilty of a felony.
Right.
And that could be held against them. I actually hear these stories every once in a while. I get people who are freaked out and they're writing me saying,
me too.
I accidentally did this and I'm afraid that someone's going to check the logs and I'm going to get fired and persecuted. But there doesn't seem to be that much momentum. There is no political will to fix the laws that haven't caught up with technology.
And it always seems like if you're the person that's trying to help the company, you're trying to bring this problem to them and say, hey, I found this vulnerability, we need to make sure that it gets fixed. If you're the person that found that vulnerability, they're going to go after you.
Yeah, there's no safe harbor for whistleblowers in this arena, and that's part of the problem. And also remember that the laws are written and paid for by the people who pay for our government, which is the big companies that have good lobbyists. So, of course, the laws are going to be biased towards not the individual, but towards protecting the corporation, the corporate status quo. I love you keep saying persecuted instead of prosecuted. I don't think we do much persecution these days, but it may feel like it, actually, but no.
Well, I come from a background where we persecute everyone. So
exactly.
That's my preferred word. Well, before we get into Santa's Little Helper, let's go ahead and take a look at an item that I thought programmers around the world probably should take a closer look at. This one comes to us from a blog by Kevin Williams called The 10 Things That Annoy Programmers the Worst. Now, it's funny, whenever we get one of these top 10 lists, there's always going to be people that have differing opinions, but these 10 are really good. The number 10 was comments that say nothing. Now, Lou, both of us know this, right? I mean, we tell people comment, 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 but there's a difference between a comment that helps and a comment that just leaves you going, okay, now what?
It's a holy war almost with comments in code. I mean, a lot of people like to over-comment, and sometimes I like over-commenting more than I like vague commenting.
Yeah.
Because if you don't comment, and then some people, the ones that do the best, actually write a design document that talks about and puts little links into the code, so you can go look at the code comments too, and that's even better. But code commenting is super important, so you know exactly what a piece of code's doing and what it's meant to do and what its purpose is to do. And then if it's breaking or not doing what it's supposed to, then at least you know the original intent.
I had to work on a project, maybe a year ago, and all the comments were, this is a loop, this is a counter, this resets the counter. I'm like, well, yeah, but why is it there? That's what that's all about. Number 9 is being interrupted by coding. I kind of thought this was just petty, but then I thought about it, and it's kind of true. Programmers tend to be the kind of people who get into a zone. It takes a while to get into the zone. You know this. You might be staring at your screen for the longest time thinking about how you're going to do something, and then you start feeling it, and you start pumping out code, and it's all good. And then someone comes in and they bother you, and it's normally something that's just lame, it's stupid. They're wandering around, they're asking a dumb question. And I think this applies. Are you like that? Do you hate it when people bother you when you're in the zone?
So I don't hate it because, in fact, sometimes I have to literally, in fact, right now I have locked my office door and there's a sign on the door that says do not disturb. But sometimes I have to do that because if I don't do that, I'm doing something, I'm thinking about something, I haven't written notes about it to kind of keep context. And so then somebody interrupts and I'm like, okay, I got to answer them and be nice. I talk to them and I come back and I'm like, okay, well, now what the heck was I doing? And so I think that happens all the time. So I think I haven't seen a tool today that can fix it, whether it's Link or Skype or whatever communication device you use that I can put that I'm busy on there. Unless I lock the door, pull my shades down, and turn the lights out, I'm pretty much open for business.
Right, right. This next one, number 8, this is near and dear to my near and dear to my heart. Scope creep or mission creep, and we all know this. This is that idea that as the project progresses, they're just going to start adding on requirements, features that they'd like, or they see something in another application and they go, oh, you know what? Our program should do that too, with no regard for the fact that might completely change what you were doing with the code. Of course, you've never run into anything like this, right?
No, never. We don't have that problem every day that I work here at all either. Yeah. But one of the biggest things that you'll see is there's an old saying, there's an acronym called MVP, Most Viable Product. And that's one of the things that startups are push very hard to do is ship a very simple thing up front, let users complain and ask for things and then add to it. But companies, whether it's Microsoft, Apple, Google, they never do that. And so there's always scope creep that come in and force the release dates out.
Yeah. Well, my favorite is the scope or the feature creep that happens, and then they expect you not to change the release date. Because, I mean, we're just asking you to add 3D features, right? I mean, that's like 2-3 lines of code. What? The next thing, I think this gets a little bit whiny because this happens for everyone. This is not just coders. But having a project manager who does not code and who does not understand or doesn't care about understanding what programmers actually do. This still does exist. You won't find this a lot at companies that are well run. But having a programming manager who cannot program it's torturous. Lou, have you experienced that?
So there's different levels of program managers. So here at Microsoft, we have what we call the domain experts and then the technical leads. And so like the domain experts are ones like, for instance, I work in financial software or business software. So ones that might understand sales and financials and general ledger and accounting. Those are actually still fairly good PMs that can understand the domain expertise around calculation and so on, but they might not necessarily understand how I'm coding it or the technology behind it. And so there's a little bit of a crutch there, but they're still fairly good PMs. And so it all depends on if you're a domain expert, if you're a technical expert, and what your project requires. And sometimes it requires both, and so that they're at a kind of a loss at that point.
Right. Number 6 and number 5 are interesting because they're kind of the same thing, but not. Number 6 was listed as being asked to document our own code. And number 5 is working on code that is not documented. And I think this is absolutely a truism. I hate documenting my code. I know I have to do it, and I end up doing it because I felt the pain of not having it. But I don't want to do it, and sometimes people have to ask me to do it. And yet, on the other side, if I find code that's not documented to my liking, I think that programmer is the worst thing ever.
Yeah, I mean, Microsoft requires what we call a white paper. So like when you do a project, you have to write a white paper about it too. And it's like, you kind of remember the old engineering English classes I had to take in college and thinking, man, I could have used a little bit more of those because I literally have to write a document that customers have to read about my code. And it's sometimes difficult to do, I guess you could say.
Yeah, yeah. Number 4 is an interesting one because I'm more of a hardware guy, but hardware-generated faults, specifically errors that are generated because we're running code, especially like beta code on janky hardware, is a pet peeve. And I've actually seen this happen a lot where we're running on pre-release hardware and we get change logs back saying, well, it doesn't work on XXY that's going to be released next year. I'm thinking, well, is that a finished version? Then why do I care? You know, if you can't show me something that they say is stable, why am I going to change my code to accommodate them? Number 3, vagueness. You know this one. In fact, anyone who's in IT knows this one. You don't have to be a programmer. That idea of, it's broken. Well, what's wrong with it? It just doesn't work right. Okay, can you tell me what happened? It didn't do what I wanted it to do. That's, yeah, you see that a lot, I think. No, you're kind of, I'll just leave you with that one. Number 2, other people. I think programmers, as a rule of thumbs, we don't like other programmers. we may understand that other programs are necessary, but Lou, and again, I'm going to throw you on the tracks here. Do you sometimes feel as if the world would be better if everyone just programmed like you?
You know, honestly, I'm going to be honest with you. So I'm only stay on teams if I have somebody who's better than I am.
There we go. Okay.
And that's the truth. And so it makes me better anyways. So I mean, if I'm not on a team that I can learn from somebody, then I normally jump off that team. So that's the rule that I follow, and that's the one that I have. But I do agree, there are some times where you work with programmers, they just don't have the skill. They maybe are just kind of just getting started, and they cause some issues. They cause some delays, and it does cause some problems with our code too. So it's a kind of a balancing act.
Yeah. And the number 1 from this posting, and yeah, this is true, my code. 6 months later, I think every programmer has had this moment where they'll look back at a program, a project that they started, and they'll go, what was I thinking? This is not elegant. This is not good. I should rewrite all of this. Of course, this happens a lot, but never at the corporate level, right, Lou?
Honestly, I've had emails from people. So I've been here 11 years. I've had emails from people that'll come be like, you wrote this, can you help us fix this? And it's like 11-year-old code. So I have that all the time. Don't worry about that.
Yeah. Now, other potentials that weren't listed in the blog, actually, my number 4 was that exactly. Answering questions about my code, especially if it's code I can't remember. I almost feel shame whenever someone says, your code is breaking this, and we don't know why. You wrote this. Can you tell us what it does? And I normally don't have an answer. I also hate code repositories with really, really bad revision keeping that tend to want us to fork projects. That's been a pet peeve of mine. One other thing is, and I've seen this in the Valley recently, star programmers, superstar programmers who are brought into a project who don't seem to ever want to program. They do all the high-level thinking, and then they leave it to the peons to turn that into code. What pet peeves do you have, Lou?
I think that is one of them. So like one of them where like they'll come up with a really, really complex design. They never communicate with the team, and then they go and say, here's design, go and code it. And then you really have no idea where to even start. I think that's the first one that I have, especially with teams. And the second one, the last one would be, if I go to a developer and they wrote the code, but there's no comments, there's no tests, it doesn't even necessarily compile sometimes, and you ask them what they were even thinking, and they have no idea. And so there's those two things, obviously, that could cause some huge blips on a project, I guess you could say.
We want to welcome to the show Mr. Carl Auerbach. Carl, so thank you so very much for coming on. I know you're a busy man. We've had you on several Twitch shows before, including This Week in Enterprise Tech. You may be a little bit of a man of mystery to many people out on the internet, but whether or not they realize it, you probably created something they're using, yeah?
Oh, almost certainly.
Yeah. Now, Carl, okay.
I am intrigued.
I'm going to ease you into this because I think the Code Monkeys are going to love knowing who you are. But let's start with something very simple, which is, how did you get into coding? How did you get into computers? How did you get into the IT revolution? You've been around for a while, including a time before the internet. So how did you get to where you are now?
Well, I was one of the infamous members of the UCLA Computer Club in 1968, next to IMP number one. And I set forth to learn basic programming. And my first language then was PL1. And it was a simple program. It took me a year to get my first piece of code running. And of course, then it was on card decks, submit them, and things like that. I happened to be also right next to besides right next to IMP number one, next to the Transportation Institute, where we're doing early car crashes. And I was hired as a film scanner, which has had these machines where we're watching cars getting off freeways from helicopters, and we were punching cards showing coordinates, and then had a big program that would use those. So I had an IBM 7094 to myself whenever I wanted. So I set forth to learn how to use that. So I wrote some trivial little programs then, and up and better, bigger and greater things since then.
Now, the mention of those systems are probably bringing some bad flashbacks to the older programmers.
Or for me, I'm going, what is
What
that?
is that? You know, blinky boxes with switches. You actually have with you a piece of gear from one of those early computers.
This wasn't that early. This was from the 80s or 70s, I mean, a PDP 1170 console.
Oh my gosh,
there it is
that
in
brings
front of you.
back all sorts of memories.
And I used to load in the boot codes into this thing and load it into memory and get the thing going.
Well, actually,
and
no,
you could tell a lot from these lights. You could tell whether your program was idling, whether it was in supervisor mode, what part of memory it was in. You could get a lot of useful data by watching those lights.
Let's talk a little bit about that, because
That's
we did
interesting.
in our first module we did a binary to decimal conversion.
Right.
And there were people who were like, well, why would I need to know binary? Well, it's because the old programmers, that's how we programmed. You didn't have a keyboard. You had to flip switches and then you committed it to memory. Could you actually show us what you would typically do for a sequence?
Well, most of the time we did the boot sequence, which I can't remember the codes, but it was something like this, and you'd store one of these switches went up to store things in memory, and then you'd finally hit the go button, which would cause it to jump to that location, which would begin to bring the system up. And that system back, by the way, at ran this was Unix.
Wow.
Well before DOS ever came out from Microsoft. So Microsoft went backwards because we had multi-user operating systems before DOS even came out.
And here we're
But that
still
was
using
late
a lot
in
of
my
the
programming
basics of
career.
Unix.
Oh yeah. Well, is it Carl? Because one of the things that often fascinates the new generation of code monkeys is when they start stepping back a little bit and they realize that a lot of the things that they're learning that they just take for granted actually have a backing. There's a reason why programming works the way it does, and that's because we're basing it off of the first generation of computers. We see that a lot. We see that in learning binary. We see that in learning hexadecimal. We see that because that's how you originally had to program these computers. Now, okay, now let's step back from that because...
Well, I was going to raise the point that most people today don't even know the difference between 1 complement arithmetic and 2's complement arithmetic.
Wait, what's the
And that's kind of important.
I don't know what's the difference.
Well, we'll get to that in just a little bit. No, but Carl, it's good that you're a geek. It's good that you're an old-fashioned geek. It's good that you were really at the cusp, the start of the IT generation. But that's not...
Oh, I'm a long way from it.
Yeah, well, yeah, but that's not all. That's not the only reason why we brought you on, right? Because you actually have a lot of experience with things that are not just hacking together computers. You're on the board of directors for the Open Voting Consortium. You're a member of the intellectual property section of the Cal State Bar. You are a co-founder for the Boston Working Group. You are part of the IETF, the Internet Engineering Task Force, and I mean you're on ICANN. So.
I affiliate with ICANN. I was on the board of directors. Most of these are past sort of things, but I'm doing new and greater things.
Yeah.
But going back to first generation coding, can't forget that the first programmers were doing the ENIAC machine and the Sage computers, and those were almost exclusively women.
Yes. Go women.
But with all this experience, with all this influence that you've had on the internet, you've seen it change a lot over the years, right? I mean, this it was a geek project at first, but how have you seen it evolve?
Well, when I first came across the internet, there was no word for it, but it was a collection of communications vehicles for us to do exchanging basic applications, email, file transfers, things like that. And we got pretty much down and dirty with the hardware, modems and wires and what have you. It's evolved a lot since then, But the first 15, 20 years of the internet were largely people playing around with not a lot of restrictions. What's happened and scares me the most recently are the changes of the legal environment around the internet, the restrictions that are arising, and the transformation of the internet into a utility. And we're not clear whether it's a utility or a vehicle for innovation anymore. Same thing has happened in programming. We're starting to see in programming used to be a Wild West thing, or anybody could write a piece of code. But we're getting to the point where not anybody is going to be able to write code for, say, the braking system in a self-driving car. You're going to need some pretty stringent tests on that code.
I want to get back to that, but before that, I think Snubs had a question about something I was talking to her about before the show, and she got really excited by.
I did. So I know that you were one of the creators of IPTV, and that's what we're doing now. This is the basis of what we have created our careers around. So I got really excited about it myself. And you were also one of the first paid employees of Precept Software before it was acquired by Cisco. So I want to know from you, how do you feel IPTV has changed since the late 1990s?
I've been unpaid early employee of several startups. I think I've done like 6 or 7. And if you want to make billions of dollars, you go to the places I turned down. But IPTV was part of Precept Software. That was a startup done by Judy Estrin in 1995. She brought me in with Steve Kasner and Chachi Kwan and her sister Deborah Estrin. And we gathered together one evening and said, what should we do? Should we do IPv6? Should we do this or that? Should we do multimedia? We said, multimedia, that sounds like a lot of fun. Well, Steve Kasner had spent a long time at USC-ISI. He was part of the team that sent the van out in the, I guess, the 1960s and 70s, doing the first internet voice projects, mobile voice. So he was also the inventor of the RTP, one of the co-inventors of the RTP, RTCP protocols. So we took that, bound it up with IP multicast. There was a model already put together by Van Jacobson on the internet, which was, I can't remember the name of it. It was what the IETF used for sharing, doing low-level videos and things like that. So we decided to start building that up and commercializing it. So what I did at this company is Steve handled all the real-time algorithms, the how do you synchronize lip sync? Lip sync is really, really hard to do, especially when you have multiple streams. And I did the RTP, RTCP code, which was a heavily not necessarily multi-threaded, but heavily asynchronous piece of C++ code that handled multiple media streams, handled the synchronization, handled the handoffs to the codecs, and all that sort of thing. We put that together into a commercial product and made it work.
I want to take a little side trip. It's going to be a small tangent, but I think it'll be worth it because I'm seeing this discussion going on in the chat room, and I actually hear this a lot, much to the ire of my embedded programming friends, and that is when people say, "Oh, well, with Arduino, now people can actually program a microprocessor," and they bristle a little bit because they were doing this way back, with Motorola embedded processors back when I was playing with my PCs. What's your take on this? Because of course, Arduino really made it popular with the maker scene. It made it possible to easily, an artist, right? You could be an artist, someone with no knowledge of embedded programming whatsoever, and you could pick up an Arduino, follow a couple instructions, read some forums, and figure out how to make something work in the real world.
Yep.
What's your take on that? I mean, it's got to be a good thing, but at the same time, I've heard you at DEF CON grumble a little bit that, well, Arduino's okay, but you can't forget all this other stuff.
I don't think it was me that was grumbling about that. I think you might have, you're probably talking about the panel I was on 2 years ago?
Right.
Okay, so that panel, actually, I think I was the one who defended Arduino because I was the only non-professional embedded programmer up there. I was the only hobbyist. So here's the thing with Arduino. Arduino took a real honest-to-goodness microcontroller, an Atmega 328. I think they started out with the 16.8, the 168. But they took a real honest-to-goodness microcontroller. It's not a toy, right? It's a real microcontroller. And they took a real C compiler. It's not a toy. This is backed by GCC, right? The most popular C compiler on the planet. And they wrapped it with a pretty interface and made it very easy to use. And they removed all of the complexity of the build chain and all of the optimization tools and the assembler and the linker and all of that crap. And they just made a simple, easy to use IDE. And they didn't say you were programming. They said you were making a sketch, right? That appeals to an artist. That's not programming. And they basically made it very non-aggressive. They made it very non-computery. And I think a lot of the computer people got turned off by that. But let me give you a hint. All you artists out there who are doing things with Arduinos, you're writing C code. You might even be writing C++ code. You might be doing object-oriented programming and you don't even know it. That's awesome. All right? So we have made it so that it is so easy to do that people who wouldn't otherwise have gotten into the hobby are getting into the hobby because we didn't say, it's like, oh, well, you've got to go, through all of these arcane steps and you have to install this package and this other package, and then you've got to take the output of this program and feed it into the output of it. We had removed all of that. And it's just, here's how you write these commands in this interpreter or this IDE, the development environment, and you click this button and it will upload it to the Arduino. Done. And that's something that artists can get behind. So they kind of took the Apple approach, right? Apple originally, the original Macintosh wasn't targeted toward computer users. It was targeted toward artists, right? They're doing the same thing. They removed all the complexities. They hid it all underneath a good UI and turned it into something that anyone can use. I think there is nothing except good to come out of Arduino. Everything that Arduino has done has been good for the hobby. Because if you have an Arduino, you can still pull out your old school development environment and do all of your same libraries, all of the same compiler and everything else. It takes the same hex file output and upload it to an Arduino hardware, and you get the nice hardware prototyping platform with all the shields and all of that, this kind of the standardization of somebody makes a module that you want to plug into your microcontroller to get it to do something, whatever that shield does. So you get to benefit from all of that for prototyping and still use your old tool chain. Or, this is actually what I do, I use the Arduino IDE, and then I make my own embedded Atmel-based projects. And I think that's what you eventually want to talk to me about, is the Darknet project, or what I did there with the Darknet ID badge. That is all written with the Arduino IDE. I just told it to output, or to build, and I went into the temp directory, grabbed the output file, and wrote my own AVRDude lines to program it out to the chips. The badge itself is Arduino compatible. You can program it with the Arduino software if you've got the right FTDI cable, which is a very standard, very common serial cable, serial on one side to USB on the other. I think it's fantastic. It's not as powerful as a lot of the commercial tools, and so a lot of hardcore embedded developers will say, well, Arduino doesn't do this feature or that feature or whatever. If you don't need those features, who cares? It really doesn't matter. And so if it gets more people into it and doing it, awesome.
Without further ado, we welcome our security expert, my security guru, Mr. Raphael Mudge, the Armitage hacker from Penn. He's a pen tester. Raphael, can you tell the folks, where they can find you?
Sure. Hi, I'm Raphael. And you can learn a little bit about the work I do. I actually develop software to hack into systems to test their security. And you can learn about that at www.advancedpentest.com.
Okay, now we're going to back up. We got the plug in. Now what we wanted to do is actually talk about you, because I know the work that you do, and Snubs knows the work that you do, because you've worked with her on her show as well, just as well as you've worked on mine. But your specialty is interesting. You go beyond white hat, black hat, gray hat. You're a guy who programs, who happens to know security really, really well. Can you tell us a little bit about your background?
Oh, sure. Okay, so what's the best place to start? I always say I'm a developer first. Everything I have or do is because I like to program. And I happen to be working in the security space. And I have my own company now, but I was active duty Air Force before for 4 years. And
thank you for your service, sir.
Thank you very much, Snubs. No, it was definitely a labor of love. I bleed blue, as they say.
Yeah.
And yeah, so, very nice. So, by the way, you see this beard? This is what happens if you apply all the coding lessons. You will grow a nice, fluffy beard.
You have,
Shannon,
you do. You have a coding beard. I just shaved mine, so I'm very, very
Understood.
clean shaven. Yes. So.
Looks nice.
Yeah. He just shaved his too. But thank you. Your beard is awesome.
I can't grow a beard.
Thank you. So, yeah, anyways, back question. My background. So, I was active duty Air Force. I worked as a researcher for the Air Force in cyber operations. And this is one Padre might not know about me. When I left the Air Force, I invented a spelling and grammar checker called After the Deadline. And I sold it to a guy named Matt Mullenweg, who created WordPress.
Oh.
And so if you have a
That's
WordPress.com, so if you have a WordPress.com blog and you go check your spelling or grammar, you're actually using my software right now to do that.
There's always a little piece of you in there. I like
Oh,
that.
yeah. No, that's After the Deadline's me.
Wow, it's a small world. That's cool.
I am a grammar checker or grammar teacher to millions of people through my programming efforts.
Raphael, one of the questions that I've had is where you get the inspiration for looking for these exploits. Because I'd say it's this weird combination. You need to be a good programmer because you need to know where they probably put the flaws in their code, or you need to know where they put the flaws in their process, which I think is what you go after. But you also need to have sort of the trollish glee of finding something wrong, finding something unique that only you would know about.
Are you calling Mudge a troll?
Yeah, in the best possible way. Mudge is a great troll. But Raphael, how do those things come together in your mind?
Okay, sure. So why is Twitter successful? This does relate to your question. Why is it easy to write on Twitter or to write a tweet?
They make it easy for consumers. They simplified it. It's very simple.
Okay, and there's one other reason too.
It's pretty?
It's track
144.
Oh, so short, yeah.
Oh, yeah. It's very short.
144 characters. Okay, so with Twitter, one of the reasons it's so popular is because of constraint. Everybody's given this default constraint to work with, 144 characters, and you're allowed to be creative within that space. And I see hacking a lot like that. Sometimes I find folks will try to pick something, anything in this big universe of all possible things to do, when what will really make you successful as a hacker is narrowing in and focusing on something. And let me give you an example from my own experience. When I was doing production red teaming, I do a lot of exercise support now, but I had just done a reconnaissance shot against my target. And what I did was I sent a web application, or sent a link to a web application to a few people in this organization. And those people clicked. It was a LinkedIn invitation. And it came to my server. And my web application discovered all this information about their systems and then sent them on to LinkedIn.com like nothing ever happened. And what that gave me was a constraint. It gave me, here's what my target has. This is the things running on their system. And now when I had to come up with an attack, it wasn't, okay, let me pick something cool that's random. It's, I need to sit here in this box I've been put into and come up with something that's going to work here. And for me, I find when I have good constraints, good assumptions, good things that narrow what I have to do, that's where the magic really happens, because I can be creative within that space and there's not that much room to spin out of control and end up in a lot of different directions.
So you like to constrain yourself whenever it comes to programming?
Absolutely. I like to constrain myself when it comes to programming and attacking something, finding the problem I'm going to use. And constraint is a beautiful, beautiful thing. And that's what reconnaissance gives you. It gives you constraints, so you know what the reality you're dealing with is.
That's really interesting. You know, it kind of makes me think of in a lot of programming, you have constraints that you have to deal with. You are restrained to the rules of a different programming language, and each one is so different. You have to stay within those rules to make your program work. So I totally get that.
Yeah, and I guess reconnaissance. So what Mudge does is when he reconnoiters a particular system, he's looking at the constraints that they work with, because that's going to necessarily affect the way that the programmers worked to both code and to guide the process of data through the system. So that's I've never thought about that, but yeah, I guess
it totally makes sense.
It really makes sense now. That's how you hunt for vulnerabilities.
And this is why we have our experts on the show.
Thank you for staying around for the best of 2014 of Coding 101. You know, I have to say, we've gone through a lot of changes. Everything from losing Snubs, who I loved working with every week, to another program, to changing the format of the show. It's one of the things that we do because we respond to you. When you tell us that you want to see certain things on the show, we try to incorporate it. And we're going to keep growing as we go into the new year, because we think that this is an important show to have. We want people to understand the world in which they live, and you know what? Learning about code is a big part of that. Now, we've got some great things planned for 2015, so you're going to want to stay tabbed. You're going to want to stay subscribed to Coding 101, because it's going to be fun. We've got Steve Gibson coming up, who's going to be showing us a little bit about SpinRite. We've got lessons for PHP. We've even got some embedded programming coming up with some members of the Twit TV army. That's right, it's going to get loud. Now, until then, I want to take this time to wish you and your family, no matter what you believe or you don't believe, just have a happy holiday. Have a happy New Year. Have a happy Christmas. Have a happy celebration of light and of life as you head off into the new year. I'm Father Robert Balasaire, the Digital Jesuit, and until we meet again, end of line. Like a boss. You see me flinch? 'Cause I didn't.